Okay, so last time we read a paper about the possible detection of some planets around some stars or substellar companions to stars. It was an interesting paper, and I thought I was thinking, what paper should I follow up reading this? And one thing that popped up into my head was the question of how they determined the mass of the stars, because we were looking at the mass of the substellar companions, so the planets, and the way we calculated that was via a formula in which you use the mass of the star. So the substellar companion's mass was dependent on the mass of the star, and that got me wondering, how do we even estimate the mass of these stars? I don't know how you do that. So I started doing my homework and reading up on that, and I then found this paper called Stellar Masses from 1980, and I think it had it had like 1,500 citations or more, and it seemed to, hopefully it will answer my questions. So I thought, why not read this, and let's see where it takes us. Okay, so this seems to be a very long paper. Yikes. So 50 pages. I don't think it'll become a very long video, so I think I'll have to edit it a bit, but that's fine. It doesn't have an abstract, so I'll just start reading it. I'm not sure what the journal is, but the author is Daniel M. Popper, and yeah. All right, introduction. In an earlier review, Popper, 1967, the problems of determining masses from data for eclipsing binaries were discussed, and some of the available results tabulated. The present review may be considered a sequel, although the most definitive visual binaries are also included. The same viewpoint is adopted, namely that only individual masses of considerable accuracy determined directly from the observational data are treated. In the first section of the earlier review, methods of mass determination based on various hypotheses, moving groups, photometric parallaxes, assumptions about the mass of one component of a binary, etc., were discussed briefly and will not be referred to. The principal justification for this review lies in the very considerable increase in available data. Two classes of binary systems are not treated: contact binaries of the WUMA class and close binaries with a degenerate component, X-ray binaries, binary pulsars, dwarf, novae. Observational status of WUMA systems have been summarized by Bienendijk, 1970, while Bakal, 1978, has discussed the masses of collapsed objects in X-ray binaries. Okay, I did some checking. Maybe it's obvious, but binaries here, of course, refer to binary solar systems. So solar systems which have two stars. This WUMA, the W is just W, but the UMA is for Ursa Major. I think it was wait. So Ursa Major is a class of binary systems in which they have very short periods. Apparently, also they eclipse each other at points, but they're very close, and so the periods are very short. And for that reason, I guess we are excluding these in this paper. But if you want to read more about it, I guess you can read Binnendijk. A list of the properties of the components of eclipsing binaries was prepared some years ago by Wood. My commentary on this list was directed primarily to the question of the suitability of the observational data for providing reliable properties. Okay, more recent tables of the properties of binary star components, in addition to the brief list in my review, have been published by Sister. Okay, so these are the papers. And then he goes on to say that these assume mass radios for many systems. Popov in particular attempted to assess the uncertainties and the resulting parameters. McCluskey, Kondo, as well as Hester included visual binaries in the discussions. Data on eclipsing binaries, including this list, were taken from a large variety of published sources. Okay, I don't know where they're going with this, but let's just keep on and let's see where it goes. Many of the results are based on spectrographic material obtained with prismatic spectrographs of relatively low dispersion, on photographic or visual light curves, or on studies in which details of the observational material are lacking. Lists are the most selective. For most of the eclipsing binaries listed in the following sections, the analysis are based on spectrographic observations obtained with grating spectrographs giving 20 ångström per millimeter or higher dispersion. In each case, I have either examined spectrograms or have satisfied myself from published or unpublished material that the spectrographic material is of adequate quality and free of appreciable systematic errors. Justifications for this approach to spectrographic material is contained in a series of papers, rediscussion of eclipsing binaries appearing in the Astrophysical Journal, and also discussed in the earlier review. Thus, the present review has more personal, perhaps more consistent standards than discussions in which published results are accepted at face value. Okay, I'm not sure if he's throwing shade here. Let's move on. The quality of photometric observations can usually be judged from available light curves. Only photoelectric data are accepted. The form of a light curve is much less clearly dependent on the values of the system parameters than in the case of a velocity curve. Hence, the reliability of photometric solution is more difficult to judge than that of a spectrographic solution. These matters are discussed in more detail in subsequent sections, as are the criteria for including visual binaries. The comments of Andersen, Clausen, and Nordström on criteria for absolute dimensions should be read in the present context. Emphasis is placed on determination of mass because it's the quantity upon which other properties such as luminosity and rate of evolution depend most sensitively. So emphasis is placed, okay, so masses are of little interest, however, without knowledge of other fundamental properties of the stars, which are usually determinable if the masses are. For visual and result spectroscopic binaries, the mass and absolute visual magnitudes are obtained directly from the observation of a particular system. Evaluation of bolometric luminosities, effective temperatures, and radii, on the other hand, require the use of scales of temperatures, bolometric correction, and absolute radiative flux. calibrated in terms of color index or some other correct correlate of radiative flux. For eclipsing binaries, it is the masses and radii that are obtained directly for individual stars, while effective temperatures, bolometric luminosities, and absolute visual magnitudes require calibrated scales. The scales adopted for these radiative quantities are based primarily on the scales of effective temperature and bolometric correction given by Hayes, which is essentially that of code L for the hotter stars, and on the scale of absolute visual fluxes compiled by Barnes. Okay. So this is interesting. For visual and result spectroscopic binaries, the masses and absolute visual magnitudes are obtained directly from the observations of a particular system. So the masses is obtained directly from the observations. What does that mean? For eclipsing binaries, it's the masses and radius that are obtained directly for individual stars. While effective temperatures, bolometric luminosities, and absolute visual magnitudes require calibrated scales. Okay, so some sort of calibrated scales, that makes sense. But I was hoping for something else than calibrated scales, but let's see. Did I go to the right page here? Yeah, okay. While Barnes, Evans, Moffat have preferred to employ the color index VR as the observable parameter correlated with surface flux. Their study shows that except for the coolest stars, the color index BV serves as well. For a given binary, the color index that is known with greater accuracy, usually BV, is used. The intermediate band index BY correlates closely with BV, so that BY observations are also employed. In some cases, it's helpful to make use of the relationship between spectral type and color index. The list of Hayes, which is an essential agreement with the compilation by Fitzgerald, is adopted. Several considerations have led me to modify this slightly the relations between visual absolute flux and color indices published by BEM. First, BEM have adopted linear relationships between FV proportional to log of flux and color index over some ranges of temperature. Examination of their data, particularly for the BNA stars, where the angular diameter results for main sequence stars are most numerous, shows that the systematic departures from linear relations are significant. Second, the scatter in the relation between flux and color index is reduced somewhat by considering BY as well as BV or ER for the calibration stars with measured angular diameters. Third, the adopted scales of TC, FV, and bolometric correction, BC, must be consistent with each other. And here's how they relate to each other. And the symbol F prime V is used here rather than FV or BEM, since the flux scale is established in a manner slightly different from that in BEM. The slight difference of a few hundredths of magnitude in the two flux scales is caused by the use of stellar absolute fluxes rather than the sun's alone, and by the adoption of Hayes scale of bolometric corrections, which give negative 0.14 mag for stars of solar color rather than negative 0.07. The reason for abandoning the time-honored value of 0.07 for the sun as the 0.4 bolometric correction is, in addition to consistency with Hayes scale, Hayes' argument that the color and spectral energy distributions are not so well known now for the sun as they are for spectrophotometric standard stars. and employing equation 1, Hayes scale of volumetric correction is adopted. Okay, so I'm gonna stop here because it feels as if we took a dive into the deep end. I have no idea what this VR, BV, BC, BEM is, so I'm gonna try and look that up a little and then see how we continue. Okay, so I went ahead and scrolled to the end of this paper just to see what they where they end up, and it does seem like there's gonna be some good stuff here, or at least the kind of thing that I'm looking for. So they say here, the attempt has been made in this review to gather together our current knowledge of the masses of the components of detached binary systems when they can be determined with reasonable accuracy. Okay, I don't know what they mean by attached here, and frankly, I don't know why they're focusing on binary systems. Maybe those are the ones for which we can estimate. Maybe there's methods we can use to estimate the mass here that you can't for solitary stellar systems. But I don't know what they mean by detached. Anyways, I love this. When they can be determined with reasonable accuracy. Okay, so this sounds like a paper that I would be interested in reading. An effort to provide realistic estimates of uncertainties of the tabulated parameters has also been made. A great deal of work is in progress on various aspects of binary star observation that will add significantly to the store of fundamental properties. The present compilation constitutes a progress report subject to continuous revision. I'm aware that the selection of data and their treatment reflect a personal point of view. And that other reviewers will make different selections. Okay. I'm gonna, even though the paper started off kind of rough, I think I'll push through, and but I'm gonna need to look up here what these things mean. Okay, so basically these indexes, what I've gathered, and this is a very low resolution explanation, but it's a way of talking about how much of one kind of light you have in relationship to another from a certain sun. So that is to say, what aspect of the light spectrum is it more of? So I think here in the VR, that's talking about that's the red amount of red light you have in relationship to the amount of visual light you have. And BV is blue in regards to visual, and yeah, so it's not more complicated than that, I think. Okay, so I've been reading along a little in the paper, basically skimming through 2 pages, just looking for some clues, and I found this on page 6. Because of effects of differing wavelength dependent line absorption, the relations between color index, absolute visual flux, and effective temperature are likely to be gravity and composition dependent. Okay, so that sounds like we're getting into some of the reasoning behind the estimation of the mass. The data for the calibrating stars with angular diameters are quite inadequate to establish these differences and recourse must be had to atmospheric models. Don't know what to do with that. Okay, reading on page 7. For each star with mass and other properties contained in most of the table of this review, an effort is made to estimate realistic values of the uncertainties of the parameter. So that's good. Considerable personal judgment is involved in these estimates. I don't know what they mean by that. In some cases, it's permissible to accept the formal mean errors of published values. But for most parameters, the formal mean errors cannot be accepted literally. Examples are parallaxes of visual binaries, okay, the plot thickens. Interesting passage here. I've jumped a few pages. This is page 32. It is rather sad in view of the very great amount of difficult observing for more than 150 years that the number of visual binaries for which masses are known to an accuracy of about 20% is not more than a dozen or so. Okay, so a bit embarrassing. I have found the reason why I'm so confused. In the beginning of this paper, Popper mentions in an earlier review the problems of determining masses from data for eclipsing binaries were discussed. And in the first section of the earlier review, methods of mass determination based on various hypotheses, moving groups, photometric parallaxes, assumptions about the mass of one component in a binary, etc., were discussed briefly and will not be referred to. So there it says very plainly, I was too quick in wanting to get to the gist of the paper, so I missed that. Anyways, I have found the paper or the review that he was referring to. So this is the determination of masses of eclipsing binary stars from Daniel Popper. So this is a paper from 1967, and I'm hoping that in this paper he will actually explain the reasoning behind the estimation of the masses of these stars. So let's get started. Before discussing in some detail problems associated with determining stellar masses by analysis of data for eclipsing binaries, I comment briefly on methods of mass determination in general. Eclipsing binaries, I think, is just a solar system with two stars in which they eclipse each other at times. So the way that the system is oriented is so that the eclipse happens in our line of sight. Direct methods of determining stellar masses are available in 3 cases. Visual binaries with visual orbits analyzed, mass radios evaluated, and parallaxes determined by geometrical means. Double-lined eclipsing binaries with light and velocity curves analyzed, visual binaries with visual orbits analyzed, and the radial velocities of the components measured. The first 2 cases provide the great majority of our information on this basic subject. Okay, so visual binaries with visual orbits analyzed. Mass radios evaluated. Okay, so the radios across the 2 stars, I guess, and parallaxes determined by geometrical means. double-line eclipsing binaries with light and velocity curves analyzed. Okay. The first two cases, visual binaries furnish masses principally of main sequence stars of type F and later, while main sequence eclipsing binaries are mainly of type F and earlier. Subgiants are found in both groups, while more highly evolved stars are very rare among binaries of either type that are amenable to analysis. Insofar as mass determination itself is concerned, visual binaries suffer from the difficulties inherent in determination of small angular quantities. The values of the masses are very sensitive to systemic errors in the separation of the components, and in the parallaxes, mass radios of close visual components are subject to similar difficulties. Okay, so I don't know what the parallax is. I don't know what the double-lined eclipsing binary is. And you talk about visual binaries. What's a non-visual binary? So I'm gonna look that up. So a parallax is how the position of the star changes as or the position of the star relative to other stars changes as you look at it from different positions. So you will look at it from one time of year and another time of year in which the Earth has changed its position. So that if there's a slight shift in the position of the star, you can use that to estimate the distance to the star. What was the other question? A double-lined eclipsing binary is simply when it's easily distinguishable which star has what effect on the spectrographic measurements, rather than say if there's one star that's much brighter and kind of overpowers the smaller star. A visual binary solar system is simply when you can see with the telescope that there is two stars. Sometimes if they are too far away, or if one star is much brighter than the other, it's hard to see that it's a visual binary, and you need to infer that from other means. Okay, so I started to go down a bit of a rabbit hole regarding this. I was hoping that the paper would go into detail regarding the methods of estimation, and I mean, sure enough, it does, but it also seems to be the case that some of these methods or parts of the methods are simply taken for granted. For example, the Kepler's laws seem to be, and some of the equations that he speaks about seem to be taken for granted. For example, the third law of Kepler. So I started digging into that, and while doing that, I realized I had to dig into Isaac Newton as well and his law of gravity, and I started to feel as if I can't really make this into a coherent video without making it several hours long. So I think what I'm gonna do is I'm gonna stop this video here, and then I'm gonna start recording a new video in which I'll go through Kepler's own notes, if I can find it,
in which he wrote about his laws, or at least the third law, which is a law that talks about the relationship between the period and the mean distance from planet to its sun. So I'll do that, and then maybe also go into Isaac Newton's notes. I'm not sure, but that will be a separate video. And then hopefully, as I've put that behind me, I will come back to this video when I have the knowledge you need to properly understand this. So that's what I'm gonna do. Okay, thanks.